Have you ever wondered how easily water can move through the ground beneath your feet, especially within an aquifer? Understanding this movement is absolutely crucial for managing our precious water resources, designing effective wells, and even predicting how contaminants might spread. The standard mathematical expression for transmissivity, which quantifies an aquifer's ability to transmit water, is simply T equals K times B here. T represents transmissivity, K stands for hydraulic conductivity, and B is the saturated thickness of the aquifer. Now let us unpack why this formula is so effective. Hydraulic conductivity, or K, is a measure of how readily water can flow through a porous medium. It depends on two main things: the properties of the fluid itself, like its viscosity and density, and the properties of the porous material, such as the size and interconnectedness of its pores. Essentially, a higher K means water can move through the material with greater ease. The saturated thickness, B, is the vertical distance through which water can flow in the aquifer. So, transmissivity combines both the material's permeability and the depth of the water-bearing zone, giving us a holistic picture of the aquifer's overall capacity to transmit water. This relationship is a direct extension of Darcy's law, which describes the flow of fluids through porous media. Practically speaking, this expression is a powerhouse in hydrogeology. We use it extensively to predict how much groundwater can be drawn from an aquifer over time and to estimate flow rates. It is also fundamental for designing and interpreting pumping tests, which are crucial experiments performed in the field to determine aquifer properties. Furthermore, transmissivity is vital for modeling contaminant transport, helping us understand how pollutants might spread underground and where they might eventually end up. It is worth noting the units for transmissivity, which typically are length squared per time, such as meters squared per day or feet squared per day. This makes perfect sense when you consider that hydraulic conductivity has units of length per time, and saturated thickness is a unit of length. When you multiply them, you get length squared per time. Determining K and B often requires precise field measurements and sophisticated analysis, often involving well drilling and long-term pumping tests. These measurements are not just academic, they are the foundation for real-world water management decisions. Ultimately, grasping the mathematical expression for transmissivity is more than just understanding a formula. It is about gaining insight into how water moves through our subsurface environments. This knowledge empowers us to make informed decisions about water supply, protect our vital groundwater resources, and ensure sustainable practices for future generations. It truly underpins effective environmental stewardship.
If you love learning about water, like, subscribe, and keep exploring with us.